The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
As the presentation says, today I'll be the director of the Silica Fume Association. I'm also the business manager of Elkem Materials, and according to the program, I also have a different title, which just goes to show after 35 years, my colleagues still don't know exactly what it is that I do. And that's okay. I think Per would appreciate that. Wasn't it a Norwegian philosopher that says, once you label me, you negate me? Soren Kierkegaard? Danish? Sorry, that's close. Thank you, Rachel. So as we talk about the performance studies of parking structures here in North America this afternoon, I'll factor in stories about Per and his influence into not only parking structures, but in concrete in general. Per was unique as a researcher. He not only saw the importance of research, but he was very keen that that research was meaningless unless we took it to the public, unless we took it to our industry. So he was a firm believer of technology transfer, those buzzwords. Sessions like today, and here's a shot of him moderating one in Tampa a few years ago. Any reason to talk to an audience, Per was a firm believer in we had good research, let's take it out to those people. One interesting thing, Per and I worked closely for the last 25 years here in North America. He was our senior research person that I relied on quite a bit, exclusively, not only in Elkem Materials, but also in all the activities of the Silica Fume Association. But one of the things that Per and I would do, and something that maybe some of you younger people might want to do at ACI, before the internet, Per and I would actually come up with a question or a subject for that ACI meeting. It could be technical, it could have been business of who's representing or what materials are doing what, but we came up with one question for that ACI convention, and then we would ask as many people as we could that question. And then at the end of the meeting, we'd get together and we'd have 100 different comments to our question, and we're able to put together a consensus of what people's positions were on various items. Embrace what you have here, people. You have 1,500 people of the highest concrete technology in the world. If you don't mind that, you're missing a heck of an opportunity. We never missed that opportunity. Per was a committee chair at 234. I was fortunate enough to have a firsthand view of what Dr. Holland and Per went through the last 3 months to put the document together. It's definitely making sausage and not a pretty sight. We build on that. Per was not a researcher that only knew what he knew. He was always looking for what is new and how do I get in front of that curve. From a sustainability point of view, Per wrote a paper back in '07 about the role of SCMs in sustainable concrete, which is still a seminal work today that I see referred to. Getting to the presentation at hand, the Silica Fume Association had a contract with the FHWA for a number of tasks, all of which Per was involved with, one of which here, the in-service analysis of silica fume long-term performance. Doug gave a presentation a little bit earlier this afternoon that highlighted in detail this whole presentation. My little segment here will just deal with the parking structures, those 4 that are already highlighted. And because Doug really beat this up in detail, I'm not going to do that, and I'll go on to the other part of the presentation. But as we all know, silica fume is not only very fine, but it's also a heck of a pozzolan. It reacts with calcium hydroxide, converting it into other CSH gel and other byproducts, a very efficient pozzolan. It's almost funny to talk about this now. I think at this ACI conference, there's 6 sessions here that deal with life cycle cost, performance, SCMs, and durability. 20 years ago, we were still debating whether SCMs and silica fume reduce the permeability of concrete. The PCI believes that their concrete, because they produce not only a high one-day strength with their accelerated cure, but also high ultimate strengths, that they have much more durable concrete than cast-in-place ready-mix concrete. When silica fumes started to enter the parking market in the late 80s, and started to land a few of those large major airport parking jobs that Doug referred to, the PCI actually funded research to try to disprove that SCMs and silica fume reduced permeability. There are papers out there, there are researchers that didn't perform good concrete practices in their test methods to achieve those inaccurate results. But the seminal work, which Elkem Materials and Pear was influential in creating with Dr. Hooton at the University of Toronto and his fine people, 3:5 water cement ratio is a typical precast mix. And if we add or replace cement with 7% silica fume, regardless of the test method used, the testing proved that you can reduce permeability 60, 80% with a 7.5% replacement. In addition to that, showed that not only did you have that same effect at the 3:5 water cement ratio, but the same effect here when you put 7% silica fume on a 4.0 and 7% silica fume on a 4.5. And here you see the 7% and 12% diffusion coefficients. One of the unique things to take from this is look at the very first chart here, the 3:5 water cement ratio without silica fume. We're comparing the first two columns to the left are ambient cured concrete. The two columns to the right, here and here, are concrete that was cured using the precast accelerated curing regime, the 16-hour high temperature cure to 140 degrees and then back down. What that shows us is that steam curing concrete at early ages and accelerating that crystal growth just created more void spaces in the paste and actually created a more permeable concrete with a higher diffusion coefficient than if you would have cured it at 70 degrees. So not only was the PCI living in a glass house, but they're throwing stones at it. They not only had less durable concrete to chlorides, but obviously silica fume has a role in high performance, as we've heard this afternoon. Parking decks. This is a picture of a garage here in Denver, probably 2 blocks away. Classic. Little bird baths where water has accumulated. You see the salt rings from the deposits of the automobiles. As Rachel pointed out, if the owner was good every springtime, they would come out and have the fire company hose all this off and get rid of those chlorides. But this is typical of what you see on parking structures. The chlorides are there, and if you don't have a maintenance practice, they are there, and they're not going anywhere. We tend to think, going into this analysis, that for this reason, the decks underneath would have been worse, because the chlorides are there and don't get washed off. Where on the top deck, like a bridge, they do. That was one assumption going into it. The Parking Committee 362 acknowledges that they have a problem with icing and salts. So they say if you're in this zone 3, the top zone there, defined as highlighted area, you should be doing certain things with your deck. In the case of zone 2 and zone 3, you ought to be putting sealers on all your roofs and all your floors, surface sealers to keep the chlorides out, or as the footnote says, silica fume may be used instead of a sealer application if the permeability of that concrete is determined to be low by acceptable standards. These are the mixtures for the 4 garages that Doug showed. Most are between 5 and 10% silica fume. All are over 1,000-car parking garages. Pretty big structures. This is the Christ Hospital garage in Cincinnati, 15 years old when this picture was taken. The texturing is pretty pronounced. And I think Doug mentioned they don't use salts on parking decks. And let me ask you a question. Why do we texture parking decks? Slip roof. Exactly. Slip roof for who? Automobiles or people? Yes. People. The designers are worried about somebody slipping and falling and suing. So from that perspective, textures can be very pronounced. And I can take you in almost every parking garage in January and show you where they are throwing salt on the garage, particularly on the roof, to prevent people from slipping and falling. Even though they say they don't, they do. I'll show you where the bags of calcium chloride, mag chloride, and salt are hidden, because they all do it. Same picture that Doug had. We pop cores out of these decks, perform some analysis of the cores, bulk diffusion, surface chlorides, or epichlorite permeability. As Doug showed the results and pointed out some of the anomalies and the reasons why the concrete looked like it performed as we had expected. Using Life 365, we were able to plow those original mix designs back through and showed that in the case of Christ Hospital in Cincinnati, we had about 24 years left on the structure, according to Life 365. The chloride profiles on Christ Hospital, however, showed that 2,000 parts per million, we were only at about half inch in 15 years, 12 years, somewhere in there. As Doug showed using that conflux model, the Life 365 said we had about 24 years left on that structure, where conflux was showing that structure had well over 100 years left on it. The question became, why did the parking garages show so much increase in service life? And Doug pointed out to one of the possibilities. The other possibility that we were hanging our hat on was that, and this is something that, again, that Per pointed out, with those lower decks in the parking garage, they don't see water. Diffusion is a steady state process where the slab needs to be fully saturated. So if those slabs aren't fully saturated, you can argue that that salt sitting on the surface isn't really going anywhere until they get fully saturated again and something happens. So maybe that has something to do with the life expectancy and the performance that we saw. But either way, Life 365 is extremely conservative in projecting service life, according to this analysis. Probably the state-of-the-art parking garage using high-performance concrete in the United States that I know of is the Indianapolis garage, opened in 2008, so 7 years ago. 5,000 cars, 1,000 car level. Each level is 11.5 acres or 500,000 square feet. The engineer's estimate was $15,000 a space. The contractor brought it in at $12,500. So if you do the math, the contractor brought it in at $7.5 million under budget. Nice back pocket there for the contractor. He did it by 163 PT placement days. He had 2 sets of form work where he could place concrete every 3 or 4 days. So he had almost 2.5 placements a week for 18 months. Silica fume, of course, throughout. The design engineer, this was the third structure in Indianapolis that he built with silica fume concrete, so the project team had some knowledge of what to expect. The center portion of the garage is the pedestrian mall that takes you into the structure. And if you don't think parking garages are important to airports, this parking garage generates over $20 million a year for the airport. It's the second biggest money maker next to the airlines using the airport. So it's a very important structure for them. In the center there, a local artist created this visual art called Breath. These red, orange diamonds actually expand slowly and contract. You can see one expanding here, and you can see one contracting here. And it's supposed to move very slowly like your lungs and be a calming effect as you're walking to the airport. But if you watch people walking through the airport, no one even notices the artwork that's there. They're just zooming straight through. So I don't know if it works. The mixture that was used, 6.5 sacks of cement, some fly ash, 6% silica fume, 3:5 water cement ratio in the winter, 3:7 in the summer. Water reducers, they needed 3,000 PSI for 1 day post-tensioning. The contractor had to have that. So they were always keeping the concrete at least 80 degrees, summer and winter, in order to achieve that. The engineers knew that if they achieved 3,000 in 20 hours, that they were going to get about 9,000, 10,000 PSI concrete. So why not use that in the rest of my structural design? And they did. The primary reason, though, for the airport selecting this was the low permeability. And if you're interested in seeing the finishing, the fast-track finishing that Terry mentioned and you see here in this photograph, it's at the silicafume.org website. The airport chose this mixture using Life 365. The highlighted mix in blue, the HPC. The goal was to achieve a 70-year design life with epoxy-coated bar, which they did. And they had a number of alternatives that they looked at using Life 365. The decks, they designed for 6,000 PSI. That means the decks were 5.5 inches thick. That's it. 5.5 inches thick. Those girders, though, are 44 inches deep and 48 inches across. They are absolutely huge. And when you put 8,000 PSI columns underneath it, the columns actually look undersized because they're not the same size as the girders that they're holding up. But you have to remember, we have an 11.5 acre roof over us, every level. And they wanted to get rid of columns as much as possible, and they wanted to reduce the column size as much as possible. Why? Safety. Safety. They didn't want a forest of columns here to obstruct the light, to obstruct everything. It's all about user safety. So if they get rid of columns and get rid of column spaces, it makes for a more open structure. By making 8,000 PSI columns and 6,000 PSI deck, they were able to create bays that were 60 by 54 feet. Count the number of spaces between the columns. There's 5 spaces between columns. You won't find any garage here that has more than 3 car spaces between a column in Denver. 5. Huge. And look at the amount of area that you're looking at 100 yards here, way out here, and that's not a forest of columns. The light's coming through, so I think the engineer achieved what he was looking for. This is a shot of a garage in Denver. Columns have an effect, and they surely have an effect if you're paying $12,000 to $15,000 for a parking place and you don't get that revenue. So column size and location are important. The fast track finishing that we keep talking about is shown in this photo. The placing, finishing, texturing, and curing all in one pass. This is a wintertime placement, so after the curing, as Terry said earlier, they'll come out and cover the placements with insulation blankets in order to achieve their one-day PT strengths. You can watch the finishing videos at silicafume.org. There's a couple finishing videos there, amongst other things. I don't know what to say about this. It happens every year. Somewhere in the world, a garage collapses due to chloride-induced corrosion, and we keep building them the same way. But in summary, in this country, we've had over 100 silica fume parking structures. Designers are finally incorporating all the high-strength properties in their design for safety, eliminating, reducing column sizes, all that good stuff that we talked about. Fast-track construction is ideal for making durable decks. You can PT them in one day so that you don't have cracking on the slabs. The case studies have confirmed that things like Life 365 is a good tool to use. It's a safe structure, reduce maintenance, repairs, and less customer inconvenience. Thank you.